Well, this time I have a little Raspberry Pi Zero with Wi-Fi on it that is connected to the Arduino Nano that's running the DHT11 sketch with Handshake. So it's um, logging the temperature and humidity um, once every minute, but it's also averaging the values. So it's reading a whole minute and then averaging the values and then sending them to the Raspberry Pi. In the Raspberry Pi, there is a Python program that is running as a fork. It's a fork process that I set up in rc.local. So it runs at boot up, and I'm now SSH into it. I have PUTTY here running on this laptop. This is a Raspberry Pi remote SSH session. And here I'm showing you on MariaDB MySQL the size of the database on which I am logging the values obtained from the temperature and humidity probe. Right now it's been running for a day and a half, and this is how big the database is. It's merely, I would say, not more than 1 megabyte, so it's not that big for the runtime has been running. Like I said, I'm right now the Raspberry Pi is running, as you can see the RX and TX LEDs on the Arduino blinking, meaning it's handshaking values with the Raspberry Pi. And you don't see anything here on the Raspberry Pi. The program itself, this is the program that is running on the Raspberry Pi, which is the first thing it does, it awaits, it makes sure the MySQL is running. So it's using the subprocess library and make sure the MySQL is running, because I was having issues with the program not running. And the reason is it was the program, the Python fork was running even before MySQL or MariaDB was loaded. So I made the change so it will wait in this loop until MySQL is running. Once MySQL / MariaDB process is running, then only then you can proceed to connect with MySQL down here. I'm in Nano now, so I'm showing you the MySQL database connection to my database and the table which I'm connected to, which is the database is IoT and the table is the DHT11, which logs the day and the hour, temperature, humidity, and it connects to the serial port. As you can see, I commented all the prints because there is no, it's a headless thing. So this has been running without any head, meaning there's no keyboard or display running in it. So there's not, if you try to print something to the terminal, if there's no terminal, the program will just halt and not run. So I don't want that. So all the print commands are commented. So there's no printing on this. All the print. So you can have all the try and accept error handling, so routines. So this is it's the same program as my previous video, except this time it's running as a fork process, so the Raspberry Pi could run headless. And let me just exit Nano here. Okay, that's a Raspberry Pi. Here I also have Python on this laptop, and this laptop was added to the users permissions on the IoT database. So this laptop and its user have access to that. So I'm running here the same program I was running with the local DHT library you have in this laptop, except that this time, instead of being, the host is not local host, it's the Raspberry Pi IP address. So if I execute this will read the values, and using matplot from Python, it will create a temperature and humidity table. I mean a plotting the values from the table from the database. So here we go. So kind of file, no such file. Oh, my bad. Forgot to add period before the extension. Give it a minute. It's a big database. So this has been running since yesterday until today. As you can see, that it's March 30th, and today is March 31st, and that is the temperature. It started raining, and it was raining all day long yesterday, and until today it finally started. I mean, like around, I would say, I don't know, late evening, just stopped raining and then slowly humidity decreased until the current value of 20 or so. No, that's actually around 40, but it went up to 85 or something because it was raining, it was pouring. So temperature is still around 17. It went down to 10. It's hovering around that value of 13. But this shows that you can have this running headless, and then you can collect the values. And this is just an example of how you can have a tiny system like this set up so you can log values into it. Actually, it's logging into the Maria database, but this opens a lot of possibilities because you can run it. You can have a remote station, and then you can just go there and pull the data out of it. And it could be a lot of things. I was also thinking, and now that I have my CANbus boards, I could potentially connect that to my car and then log values from the car, like fuel values, RPM, stuff like that, and just dump it into a database and then just collect them to analyze it. So it's like a logger, if you will, but it's open source. Well, this is it. A headless Raspberry Pi logging values into a Maria/MySQL database, and then plotting them into a matplot plot in Python. Thank you for watching.